My name is Pratikor and my UNUK ID is 164023555. This is the assignment for wireless and advanced technology SAME 6. The topic of my assignment is Green Mobile Network for Wireless Sensor Network WSN. Our research focuses mainly on base and core level to save the energy and optimize them because the energy could be finished any day. Now we have to make a big effort here. Starting with the green mobile networks. As there are advancements in the technology, 3G has developed to 4G and various multimedia transmission technology has advanced in such a way that the server has become so high and the data compatibility are also so high, using more energy and simultaneously increasing number of users has led to emission of CO2. Um, and ICT conducted a research in 2007 and it found that only ICT was responsible for 2% increment in carbon emission, and by the year 20 it will be up to 6%. Now see, ICT, a single institute ICT has been using energy in such a way there are billions of such industries now. We can think of a world with more CO2 and less O2. This could have a big deal here. Um, our research people have a guidance and conceptual and directional movement towards energy optimization. We will be dealing with various optimization techniques and on component and system level, not only system level, on the network level, how the topology are determined with proper routing paths to save more energy. Uh, one of the approach to save energy is by reducing the frame per second color density and contents bitrate of an application in such a way that they use low minimum power and but it has to perform in its efficient rate. Efficiency should be there and the energy should also be consumed. uh, and harvested energy from environment plays a significant role in wireless network pattern. Energy also could be harvested from the environment. The main goal of the green mobile network is to contribute their some effort to make a pathway for the generation to generation on green earth. uh, this is the wireless sensor network. Now let's talk about the wireless sensor networks. Wireless sensor networks are those sensor networks which has one memory to store the data gathered from the sensor nodes, a microprocessor also called as a computational unit to compress and decompress the data, a sensitive server to optimize the sensitivity of the program they are being held to, and a radio unit to transmit the energy into the base station. They can be performed on various fields: environmental architecture and medical factors like thermal heat, medical detection, volcanic eruption, structural monitoring. Anyway, this wireless sensor has shown its productivity and efficiency in various fields, not only in the medical fields, also in the home security and artificial intelligence. WSN has been successfully working. WSN has been deployed in various natural habitats to cope with the habitats that the animals are living for, how they live, what they do for survival and everything. A wireless sensor network could do it, and they are of two types: one, battery operated, and second, wired cables. Wired cables could be hard to be configured on the natural habitat, so battery operated wireless sensor networks are mostly used. Thus our research paper begins to save the energy in battery operated WSN. Let's talk about the wireless sensor node architecture here. As I said, there is a battery that is DC to DC converters, which has a sensor unit. Sensor unit is forwarded to computational unit, which contains a memory and a microprocessor, and then a radio unit, which contains a radio to transmit the information gathered from the computational unit to the base station. base station determines what to do with the information, to transmit it to the neighbor nodes, to calculate the precise data, and to do every calculation is done there. Let's talk. This is the energy model. This is the radio energy model. Trans Transceiver socket energy is the main component of radio energy model to enable transmission signal energy. Usually distance between two transmission are quite small. Thus, the transceiver circuit and transmit signal energy has to contribute a big role. First, the figure A is of the transmitter circuit and figure B is of the receiver circuit. The components of the circuits are been shown here. For first one is of the uh, transceiver circuit energy. The components are DSC, digital to analog converter, which is forwarded to LPF, low pass filter. Then there is a mixer which has a frequency synthesizer, and then passed again to power amplifier, thus ended with band pass filter. In this way the transceiver circuit flows. The below there is a receiver circuit. The receiver circuit also flows in the same way. The energy could be calculated by the total sum, of energy, um, by the total sum of energy calculated from the nodes and the total energy calculated from the base. When we add these two parameters, we will get the sum of the total energy, and thus we can decide what to do with that energy, to save it, to optimize it, to waste it. No, no one would waste it, everyone would save it. Now I want let's discuss among the estimated power energy. Let's talk something about here, how the power is estimated, how the power energy could be estimated. Simply, as you can see here, that energy consumption mostly depends upon two entities: system architecture and set of instructions. Both these components should be selected in such a way that they meet low power consumption and high performance efficiency. Application specific integrated circuit ASIC is used to program on low power, but but because of the complex nature and the advancement of the IT technology, it's hard. It's hard to use this technology, you know. A, then a low processor is used after it. Usually, what was done at the past decades was energy was being saved at socket and gate levels, but nowadays these such tasks are time consuming. Time is more than wealth nowadays, so time consuming is also a big challenge to meet with. Then power consumption should mainly be performed on instruction level, as socket level and gate levels are time consuming, so we move on to the instruction level action. The power consumption is being done, and to calculate the total energy we add the base energy and the energy calculated from the instruction set. In this way we can calculate the energy being used by the sensor nodes and the base energy, or what we call a base station. Now, I have enlisted some of the energy optimization techniques being classified into two terms: compo compo component level energy optimization technique and system level energy optimization technique. In component level energy optimization technique, there are no subtopics, but inside system level we will be dealing with computational communication energy trade-off, dynamic power management, dynamic voltage frequency scaling, and network level energy optimization. uh, by the name we can clarify that component level energy optimization techniques is the saving of energy in componential fields like sensor nodes and WSN. We can save energy on various parameters like computational and radio unit. We can work on those fields, and the uh, sensor nodes should be selected in a such a should be selected in such a way that they have to be superlative as they are responsible for working on minimum power. I have shown the two examples that uses less power at mega 128L and TIS MSP430 are the two sensor nodes that work on low power with high efficiency. Uh, Power saving is not is the only one factor to deal with. Similarly, processing ability is the another factor. If the processing ability is time consuming, then there will be no any efficiency in running the devices in low power consumption, because low power consumption will take the same time, and as seeing in average the energy will be same. We have done the work, but there are no efforts and no results seen after then. So fast processing ability is also important factor to be considered here. Memory. Depending upon the memory, sensor nodes calculate what to do with. In various environmental factors, like when a sensor node is deployed in a habitat to learn about the nature of the lion, it has to deal with the various factors like thermal sensing, video capturing, audio, and all these functionalities are to be recorded somewhere. So a memory has to be configured, and those memory are either executed by a RAM or SD-RAM. It depends upon the administrator what he chooses to do. Techniques are classified in architecture, circuit, logic, and system level. These are the parameters in which the techniques are classified, but those functionality are not further enhanced. Let's talk about the system level energy optimization techniques here. First one is the computational communication energy trade-off. What we do here is we trade off the energy between the computational unit and the radio unit. Saves energy in radio unit through less transmission of data. Encoding schemes are used for this methodology. Let's talk about a simple example here. In channel encoding is the best example here, as bit error rate uh, should be less much lesser in the medical fields as compared to the environmental factors. In environmental factors, when we deploy WSN in for thermal sensing, the data that we allocate or we gather could be of any range. But when we're talking about the medical sectors, the BER must be the minimum, because they are high risk here. Any simple error could cost a life of a human being. So BER must be less. Computational communication energy trade-off, simply what it does is, uh, first the wireless sensor network gather data from the sensor nodes, then it does compression and decompression on the computational unit and send the data to the base station from radio units one by one. Now we change of this process. We do in compression and decompression first. After it is being held, we do the radio unit, and we just transmit that data, and we do the calculation in non-energy constraint based energy, where the energy is most optimized. Let's talk about the dynamic power management. Dynamic power management is the technique to change the state of device into shutdown and awake state with voltage regulator off and power down components. The de the device the device could be the sensor node components must be switched to sleep mode to optimize this functionality, and the task scheduling could be done, and task scheduling has to be done efficiently, as it determines whether the operation is to be in the shutdown or awake state. Dynamic power management is efficient if applied with computational energy trade-off. Both these techniques can be collaborated and make as one to implement this functionality more betterly. Next is dynamic voltage frequency scaling. Here we supply less voltage and frequency to the computational and radio unit. The dynamic and static energy consumptions are contributed. While the device is charging at states, there is fluctuation of voltage in switching capacitor by continuously charging and discharging. And from here, dynamic energy consumption could be estimated. Leakage current is responsible for static energy consumption. These are the formulae for determining uh, dynamic energy and static energy. Last, we talk about the network level energy optimization. Energy optimization, network level energy optimization depends upon the network topology, routing paths, redundancy management, and data transmission protocol. More the routing path is better, the energy will be more optimized. As as cluster head collects data and transmit it to base station, so positioning of cluster head and its strategy plays a vital role. The less the number of hope, the more the transmission distance and the energy is. So we have to make a large number of hopes so that the transmission distance between the 2 points gets smaller and energy is being saved. Base stations should configure routing paths efficiently to calculate precise decision during communication with neighbor nodes. Base station is responsible for transmitting the data into neighbor nodes to calculate and get the precise decision. So base station also need to be configured properly. Uh, let's talk about the limitation and resource gap here. I haven't further enhanced the components of component level energy optimization, which could be further illustrated. And in the component level energy optimization, user is limited to scale settings on development level, as they have no privilege to the as they have no privilege as of the administrator. So they may save the energy or they may not save the energy. It literally depends upon the administrator what he has programmed to do. Low power usage causes device to work less productively. As mentioned earlier, low power usage causes less productivity, which produce the same result. The genetic algorithms could have been also defined in the energy optimization techniques, but these are the research gaps. And messy network topology leads to consumption of more energy, and deep initialization of programming techniques could have been also further enhanced. Concluding this project, sensor node gather data, process and computational unit and transmit through radio unit. Energy has always been a limited source, so saving them is most important factor. Different optimization techniques are analyzed and illustrated, and a simple step towards energy saving could enlighten the whole world. Thus we conclude this assignment. Thank you.